Good morning or good afternoon or good evening, depending on your time zone. And welcome to this Syncfusion webinar, which we're going to be looking at designing enterprise level in systems from idea to product.
Yeah, absolutely. Hi everyone. I'm super glad and very honored to be a part of this series. To kind of do a webinar with Syncfusion. This is my very first time, to do something like this. Um, Let me just tell you a little bit about myself, what I do, and I know probably Carter told you a little bit about that, but just real quick here, I've been doing software now for almost 21 years. I'm a senior engineering manager at Microsoft. Software development, didn't come to me as easy as it might come to some folks. Exactly not the sharpest knife in the drawer. I like to take my sweet time to kind of understand how things work and, a part of that, some 19 years ago, I decided, well, how can you flip something that you might see as a shortcoming within yourself into an advantage, right? I said, okay, if it takes me so long to actually understand a certain concept or a certain idea or a certain complex system, maybe I need to simplify it. Maybe it is, more complex than it needs to be. So I decided to kind of come up with a simple theory, a simple idea that allows me to understand any system out there. In order for you to be able to understand any system, you need to find the commonality between any system out there. We are biosystems and we are made out of smaller systems. Our brain is a system, our heart is a system, systems into systems into systems. This is everything that's out there down to the smallest system in the universe that we know of, which is the atom, right? You have electrons going into orbits and protons and neutrons, systems everywhere, right? I thought to myself, okay, I need to come up with an idea or a theory that simplifies systems for myself so I can teach it to the world and so I can progress in this craft because I love software engineering. I just can't wait to see, how I can build great things, into this world without actually understanding how software works. So I came up with a simple idea, a simple theory, if you may. I called it the tri-nature of everything. This tri-nature of everything theory basically says this. Every system out there that you can imagine consists of three main components. And these three main components, I'm going to share my screen here real quick. There you go. What's the most famous word in 2020, 2021, 2022? Can you see my screen? All right. What do you think, Carter? Is my screen visible for everyone?
Yep, it looks good to me.
Awesome, awesome. So okay, so let's just break every system in the universe into these three components. Let's test our theory, and then let's take that through our software development life cycle and system design and architecture. Any system that we know of either has a dependency, it depends on something, or it has its own purpose to survive, and it has an exposure component. That's how it presents itself to the outside world. That's how it allows other systems to interact with it. What's a good example of this? Us as human beings, right? We rely on food and water to survive, and then we have our own purpose. Maybe we write software, maybe we like to draw, maybe we like to, I don't know, we do mathematics, whatever your purpose is in the world, whatever that gets you, excited. And then we also allow ourselves to interact with other people and other things out there through, communication. We send emails, we say things, we see things. That's an exposure layer that allows us as people to communicate with other systems and also allow other people to communicate with us, right? Like how are people are supposed to hire me as a software engineer if they don't know what I'm doing? So I need to go out there and make a resume and make a profile, and then these other folks can come to me and communicate with me. If you think about, I'm going to intentionally kind of color these, just for a very specific purpose. And we're going to talk about that in a second, right? So any system is a dependency and a purpose and exposure. Even your computer, right? Your computer is a system that relies on the electricity and the power to power itself up. So that's a dependency. It has a purpose, which is computation. And then it has an exposure layer, which is the keyboards and the monitors and everything you use. Everything around you is just like that, from the smallest, minute, simplest thing in the world to the biggest thing to the galaxy system. It's nothing but systems that fall within these particular patterns. So if you think about it this way, then we, in this whole massive, amazing complex system that we live in, are nothing but just systems connected to each other. Many, many systems communicating with each other on daily basis. Every single second, every single femtosecond of every day, the dependency of one system is the exposure of another. The dependency of one system is the exposure of another, and so on and so forth. You'll see, this is happening everywhere. People, kind of read a blog post from some programmer, so you can learn about, let's say, how you use Syncfusion, for instance, so you're learning, that's your dependency. You're relying on the internet, you're relying on blog posts to learn how to, build a certain system, and then you use that to fulfill a purpose, and then you go build a website so some other systems can actually communicate with it. It's exactly the same thing. But having theories is great, but it's not always bunnies and rainbows out there, right? We could have all the theories in the world, but unless we can actually apply that theory in real life scenarios, it won't hold any water. It won't actually stand a chance. Where do systems design and architecture start from? It always starts from a what I call a raw requirement, right? Someone coming in and saying, "Hey, I want you to do something for me, and I want you to design this system, and I want you to," or maybe that very customer is just you. Maybe you have an idea of the next big thing that's going to change the world, the next big app, and you need to write down what this app and what this system and what this application is supposed to look like. So let's just take an example here of a simple requirement. I'm going to put this in here like this, and I'm going to go here and call this a requirement. So here's our requirement. And this requirement basically says this. I would like a schooling system. Let me zoom in a little bit here. That allows students to register to courses and view schedules. Just like that. A simple requirement that is coming in to you as a program manager, systems engineer, whoever, whatever your role is, and you need to kind of fulfill that purpose and make it and turn it into a real system in the real world. If you look at this requirement just the way it is, you might be missing some details. You might need not be paying attention to some certain, things that might not be visible to you as an engineer, especially if the requirement gets bigger and bigger. This is just a sample shred of a requirement, but requirements in the real world can come in 30 pages vision document that you need to break it down into systems that can actually go out there and actually perform a certain task. Let's do this little practice together. We're going to go in here and basically mark the nouns in this requirement with a certain color. So I'm going to mark the nouns in here with the green color. So these are students. These here are students and schedules and systems. And here's the courses. And I'm also going to mark in, all these little components or models in that requirement. So I picked up the nouns, just nouns. You don't have to think about what they are or what they do. Just the nouns. Pick up the nouns and then put them into boxes like these. This is a process called modeling and simulation, purposing, modeling, and simulation. So here's my schooling system in here. Schooling system, that's one model. And I also have a student just in that exact order. So that's my student. And here's another model in here that is a course. And here's another model that's a schedule. Okay, so these are the models in that system. Now, in order for us to implement the simulation, which is the interactions between these different models, we need to go after the verbs in that particular requirement. So let's pick up this verb here. It says allows students register. So a student is registering into a course, and a course and a student wants to be able to view their schedules. Okay, so now I see these verbs. These verbs are going to be the edges that connect, these models together. So I see in here, a student is supposed to be able to access a particular schooling system because we said allows, so that student needs to be allowed to enter that system. Also, a student needs to be able to register to a course. Fine. So let's pick up that student model in here. And let's say the student in here is basically registering to that course. And then the last thing is that the very same student model will be able to view a schedule. Right now, let's put some names on these, edges in here. So I'm gonna double click on that guy in here. I'm just gonna say login. I'm gonna go here and say register, and I'm gonna go here and say view. So just like that, I picked up a raw requirement, that may or may not be formalized in a certain way, and I turn it into a bunch of models, and these models are interacting with each other. How is that gonna help me with designing my system? Let's take a look. So in here, basically, I'm going to go and say, let's implement this particular feature. So this feature in here is basically a student being able to view their schedules. Well, what do I need to allow a student or an individual to view schedules? Well, I need to store these schedules somewhere. So maybe I need a storage sitting in here. Let's call this our storage. And also, maybe I need an intelligent unit, something that holds my business logic, something that goes and says which student should see which pieces of information. Is this student enrolled in the school? Did they actually pay their dues? Are they able to, retrieve these schedules based on the most recent date? So many different things. So maybe I need an API sitting in front of this storage to kind of identify and implement, the business rules that fulfill that schooling system that I want to build. And maybe in front of all of this, because not all the students in the world are going to be able to make RESTful API communications, we're just going to have a UI component sitting in here. And this UI component will allow these students to communicate with the API, and the API will basically go pull from the storage. What I just created here right now is a dependency and a purpose, operations, and an exposure layer, just like we talked earlier. Okay, but this is a very simple system. Complex systems can get bigger than that. But before we do that, let's just dig a little bit deeper into the API and see if this tri nature of everything theory is actually true, then it should represent a fractal pattern. A fractal pattern basically means that the system, the massive system that we're looking at, if you break it down into smaller systems, they will follow the exact same pattern as the larger one. Okay, so let's zoom in a little bit into this API and let's see what this API would look like, right? If I were to design a simple API, let's say just a simple ASP.NET API, that you want to work with, a simple API would need three different components. It needs something called a storage broker. Let's call it schedules storage broker. And what this broker does is that it abstracts away all the details about communicating with a storage unit, or a storage component in your system. So your core business logic doesn't need to be tightly coupled with SQL or Cosmos or MySQL or anything else. It just knows that it needs to talk to some dependency that fulfills a contract called iStorageBroker. And then it takes that dependency and goes and communicates with this whatever storage system that's underneath that particular contract. Okay, so this guy, knows the connection strings and the security and authentication authorization pieces, and it fulfills a contract. But you still need something to run in here. Schedule service. This is just a C# class service or a Java service. Doesn't matter. It's just a simple file that contains your business logic. I call them services. And what this guy does, it does the validation, the conversion, processing, all the business logic operations that makes your software different than anybody else's. So think about these schedule service as your DNA. It's the one thing in any system that actually makes your system very different from another system. Otherwise, everybody's talking to a database. Everyone has a UI. Everyone has an API controller. Your services are the ones that really identify your purpose. Emphasis there on the purpose because we're going to come to this piece in a second. And then maybe in front of this service, we need something called schedules API controller. And this controller is how your API is exposing its capabilities to the outside world. In order for you to communicate with an API, you need to hit that API controller endpoint to be able to consume its data and consume its services and all that. If this is the zoomed in version of this API that I did here, I'm going to give it a scope here just so you can see. So this is a zoomed in version of this API. You'll notice something very interesting. This very same purpose component already has its own dependency piece, it has its own purpose piece, and it has its own exposure piece. So that big system that had dependency, purpose, exposure, within itself, inside that API itself, you will find the exact same pattern repeating itself. This is how I'm simplifying, the most complex problems in the software world. And we're going to build on top of that. And you're still going to be able to, keep track of what I'm saying because it's already following that exact same theory. Okay, well, let's test this a little bit further then. If this is true, I'm going to pull these guys down for a reason. I'm going to show you in a second. If this is really true, then when I go and design my UI, I should be able to fulfill the exact same theory then, right? Let's go and design the UI together and see what that looks like. Here is our UI component that is supposed to kind of give me the capability or give students the capability to communicate with, an API and view their schedules and calendars and all that kind of good stuff. Well, how do I design that? Well, I need an API broker, something that holds all the integration details, security, aspects, tokens, whatever, secrets for your API, whatever you're doing. And then maybe you need a service layer in here that maps external models into local models, model, view model kind of thing. So it picks up your models from the API and turns them into something that is easily digestible and consumable by the API, by the UI. And then maybe in front of that, you want to build a UI component. And this UI component in here is not just a simple UI component. It's a component that is specifically tailored and designed to render students' schedules for a particular student. So maybe it takes in as an input parameter, maybe through a passed in kind of a Blazor. If you're working with Blazor, passed in parameter or prop and React, if you're using React, parameter that says, here's the student ID. I want to view the schedules for this particular student, right? And this component picks up that ID and sends it to the schedule service, which goes and calls the API and does all the magic to get down that data. So let's call this student schedules component, right? So this component is tailored specifically for student schedules. This component in and of itself doesn't really hold any native or external components. What that basically means is that it doesn't go and call, an external third-party UI provider component directly. It has an abstraction layer between that. If you're using, Syncfusion, for instance, you're not really calling Syncfusion here directly. You're building something called a base component. And this base component is a wrapper around that third-party provider. So if you're sitting in here, you're basically calling the third-party provider, let's call this a Syncfusion, and you have something in here called calendar base component. Right. So this calendar-based component and the Syncfusion calendar piece, this wrapping that's happening in here is purposeless. It doesn't know what you're going to be using it for, right? It just sits there and it says, whatever you want to use this component for, just give me the data and I will render it for you and I will give you capabilities. But you still need to do the hooking up between the, integration pieces, getting that data, and then actually, passing that data to that component. And then this student schedules component could use multiple base components, but that's your base component right here that it leverages to kind of render that data. And maybe on top of that, we need a web page sitting in here. If you're building a mobile app, it would be something like a container or a form, whatever the case may be. And let's call this students portal, something that has a route in it that basically goes and says, for every student that want to view their notifications and calendars and, and view their courses and everything else, go here. And I'm going to go find all the components. Imagine this is multiple components sitting in here, right? And this portal is pulling all these components together and building a nice, sweet UI and a page that basically renders all that information for you. I'm going to show you an example of this in the real world in a second. If you look at how we designed our UI here, you will notice something very interesting. The UI itself has an exposure layer, a purpose layer, and it has a dependency layer. Just like how we did with the database with the brokers. It's exactly the same thing. If you look at the flow where the data starts, you're starting from the web page up here, and you're working your way up in terms of rendering all the way down to your third-party provider components. But also at the same time, you will see the opposite, kind of not exactly the opposite, just the other dimension in here. You're going and pulling your data in that direction. So this is how this one component here is pulling data from one direction this way, and the UI and the rendering is coming from the top to the bottom. They intersect with each other. This student schedules component actually renders a business flow that is actually usable for a particular business need. In our case here, just students being able to view their calendars and schedules. This would be the zoomed in version of designing a UI component. And back again, it confirms the theory that we are actually repeating that same pattern, the tri-nature pattern of everything, where you are kind of repeating over and over again the exact same pattern, back and forth. Like this is your dependency, these two components are your purpose, and then again, dependency, purpose, exposure. If you remove these two, this guy becomes an exposure for this component contextually. But in the bigger scheme of things, it's actually holding its own purpose within this other dimension or this other direction. The same thing happens with the database. If you go back to the third piece in here, the database, if you ask the Azure SQL team or, MySQL, whoever is providing, database services, they will tell you exactly the same thing. We have a file system. That's our dependency. This is where we read the data from. We have an application layer on top of this that translates SQL queries into a mechanism that can actually search through these records and actually pull the data out of it. And then we have an exposure layer. If you go to Azure Portal, for instance, that's how you interact with the database and consume data from the database, right? So whatever is out there will fall within that realm, one by one. Before I take this into a larger distributed complex systems, maybe microservice architecture, something like that, I'll just wait 10 seconds. I know, Carter, for people to ask any questions. I don't know if you have the chat, available for everybody. Mm,
Yeah, I believe that the chat should be available for everyone right now.
okay.
Everyone, please let me know if I'm incorrect on that. But as like right now, I don't believe we have any questions that's come in
Okay.
yet. But
Okay.
I would like to take this time, like you said, while we have some time, just to say if anyone does have any questions, please go on to the chat window. I will be reviewing any of those coming in, and I'll be sure to relay them as they are asked.
Okay.
I know a lot of you are adjusted to we use GoToWebinar, so we've switched over to Teams meetings. So there's not a question or answer tab. It would just be in the chat, so you can insert it in there, whatever you have a question.
All right. Okay. All right. Thank you. All right. Okay, let's take this further. Let's go from here and go a little bit further. Well, it's not always bunnies and rainbows out there. This is a very straightforward thing. Anybody that has been in the tech industry for, say, 2 or 3 years will tell you, well, systems are not really that straightforward. You don't just go and pull data from databases and then just pick up that data and go render it, into the UI. There are multiple flows and multiple entities involved into delivering a particular feature, and that's very true. So we need a theory, we need an idea and a pattern that allows us to kind of formalize and standardize the intersections between, let's say, two different entities, like a student and a schedules. I want to check the student's status to see if they're enrolled actually in the schooling system and to see if they paid their dues before I allow them to register to a course. I see a question here real quick, before I move forward with that. Within the API, that's Ryan. Within the API, would you have a different schedule broker for each storage engine, or would you manage that in a further broken down method? So let's say you have, for instance, this is a great question actually. Let's say you have in here, if I understood that question correctly, if your contract is called I storage broker like this, let's go here. If you have like I storage broker like this, and you're implementing that contract by creating something like SQL Storage Broker, and maybe you did another implementation like Cosmos Storage Broker like this, or maybe MySQL or whatever. These are all, concrete classes that implement that contract. If you're running on an ASP.NET Core, for instance, you can so easily go and say, based on the service, I want to choose and determine which concrete implementation I want to work with based on which technology, and you could still work with the exact same model. I don't know if that answered your question, Ryan. Mm. Okay, perfect. Okay, so let's go back to this. All right, so let's complicate things a little bit, right? Let's say, you have cross entities kind of flow. I want to check if the student is actually has the right status. So let's go here and build maybe a student storage broker, something that talks to the database. And I also want to have a student service. So that's your student service. And this service is just doing all the work. These guys are just happy, they're working with one entity, single responsibility, no problem there, right? But we also want to combine them with another entity and another purpose that allows us to complete a little bit of a higher order business flow. So I'm going to go here and say maybe this is courses storage broker, and I want to go here and say this is course service, right? I want to go and check the student and see if that student is enrolled in the school and they paid their dues before we register them at this course. How do we do that? We can introduce here something that I call an orchestration service. And what this orchestration service does, see, if you really want to achieve single responsibility, then every class should either do the work or delegate the work, but not both. If your class is doing the work and delegating the work, something is absolutely wrong with your design. And I'm just going to say it out there. Something is really, really spaghetti code in your system, and you need to rethink your system, right? This is what this guy is going to do. It's going to go and say course registration, orchestration service. These are all just C# classes. And when a student wants to register to a particular course, it sends a request somewhere through an API or a UI, whatever you want to send that through. And then what's going to happen here is that the orchestration service is going to delegate the work of verifying the status of that student that they are enrolled in the school through the student service. You see, the student service itself becomes a primitive component. It doesn't know what it's being used for. It just this student service, it just knows that it needs to go pull students based on their ID. And if that student doesn't exist in the database and doesn't exist in the system, then it will go and say terminate the entire operation, break the circuit, because you can't register a student to a course that if that student doesn't exist. All right. Once it goes and says, give me the status of this student, and it makes sure that it's okay, it will go and try to register that student into the course service. So it will go and say, check if that course is actually still valid and has open spots. But more importantly, go and check if that student didn't already register in that system. If we make our system a little bit more complex, we can go and say, okay, maybe the course has schedules added to it, so I can complicate things a little bit without actually breaking the simplicity of my design, and go and say here, okay, this here is going to be my schedules storage broker, and there's my schedule service. So you can pick up the student, sign up to the course, and find an open, calendar spot for them, all in one shot without actually complicating your code and doing, more than just one thing per class. I see another question here that says, on what layer do you implement data validation? On the service layer. On multiple or just one component? On the service layer. The service layer here, these guys in here, this layer in here, this guy will validate only what it cares about. In this particular case, it will validate any incoming data, and we will talk about that a little bit down the road. It will validate the incoming data, make sure it's in a good state before it does processing and does persistence. This orchestration service will validate only what it cares about. So if it's receiving a student ID and a course ID, it will just make sure that these IDs are good, and it doesn't really care about any other details because that's its part of responsibility to validate. So you see the validation here becomes lesser and lesser the higher you go in the chain of services or business logic. So you can only do what you care about or what you use. Of course, these guys here is what I call a foundation service or broker neighboring services. These are your brokers. These are your broker neighboring services. And these guys validate everything. everything. They make sure that the data is 100% correct before it persisted in the database. I see another question here that says, okay, you know, Claris, I don't know that language. It says multiple. You know, you probably want to clarify that one. I don't know what that means, but anyway, let's move forward from there. So this is all living in one microservice, right? So this is your one microservice sitting in here, and you're basically going and saying that maybe I have a controller sitting in front of this these services. Let's call it course registrations API controller. And this course registrations API controller is just your exposure layer, and it receives a request to register a student in a particular course and find a schedule for them automatically. And then it comes back with that result. This is all encapsulated within one tiny microservice, just like that. But in the real world, if you're not building a monolithic application, you're going to need to break your domains into smaller microservices. Let's do that exact same practice in here with a little bit of a larger scale of a system. So let's say you have students microservice. So this microservice is not just persisting one model of one student. Now it has all the domain information about the students. It has a student attendance, student details, student contact, all the little details that you can imagine about that big student domain in this microservice. And maybe it owns its own storage, as it is the case in microservices. Every microservice should own its own resource. And maybe we have something similar to that in here. We have something called, courses microservice. And this microservice is doing the same, except that it doesn't rely on a local storage. Maybe it calls a K12 external API to kind of, pull its data and all that kind of stuff. Okay, we built two microservices in here. In order for this microservices architecture to be useful, we need some sort of an orchestration microservice that doesn't necessarily own so much resources, but it knows how to orchestrate flows into the system. Let's call it school microservice. So this school microservice will receive a request that says, give me all the students and all the courses that these students are registered in. And this guy knows how to go and talk to this service, pull the students, and then pull all the courses related to them, and then shoot it right out through the API. In a microservice architecture, you're not supposed to expose your microservices to the outside world. You're supposed to kind of put an exposure layer, some gatekeeper or a gateway that protects and decouples your internal system from the outside world. Usually what we do is we put something called a gatekeeper or a gateway. And this guy, all it does is that it takes care of the security authorization authentication, but also at the same time, it routes external calls into internal calls. This way, if you decide to completely reshuffle and rebuild your entire internal microservices architecture, your client will be none the wiser because they're only interacting with this exposure layer. If you look at this microservices architecture that I just draw for you, just right now, you will notice something very interesting. We just created an exposure layer, a purpose layer in here, and we just created dependencies for that purpose layer. The exact same way we built the smallest microservice. The pattern continues to repeat itself over and over and over again. The same way we developed this higher level system, the same way we said we need to have a dependency and a purpose and an exposure layer. It just keeps repeating itself like that. But if that's really true, then let's zoom out a little bit. If you're in a big enterprise system like Microsoft, you have many, many different teams communicating with each other. So maybe this is Azure SQL team, or maybe this is a different team in here that's sitting and providing app services. These certain components that you might use in the cloud have entire teams working behind them that actually support them. So maybe, we're relying on SQL team to run our SQL database, and we're relying on the app service team to run our database. And maybe this is some cash flow service that allows people that visit Microsoft.com to make purchases, and we validate their credit cards, we validate their information, we make sure they're not on a do not engage list and all that kind of good stuff. And maybe in front of all of this, you have the front page, which is Microsoft.com. When you go to Microsoft Store, you go visit a simple page. That page has its own team, it has its own orchestrations, it has its own work going on. See, cross-team and cross-organizational communication still repeats the same pattern. You have dependencies, you have purposes, and you have an exposure team. This is cross team. You have the core team sitting in the middle doing all the magic and the business logic orchestration. You have other teams just building your dependencies. And then you have a third team sitting up front, or a fourth team sitting up front. And that team, all that it's doing is that it's reading that data from everywhere and rendering it on the screen on a web page like Microsoft.com. I see another question here. It said, where do the routes sit in this process? In the microservice architecture, the routes will sit in, so you have your routes. So there are two routes in here. There are internal routes. So every one of these services have their own route, right? And then this guy knows about these routes internally, but it's exposing a different public route, right? It all sits in your gatekeeper component. That gatekeeper component is the one responsible for taking that external, request that's coming in and mapping it and routing it back into your system. Of course, someone might say, well, where you put your API manager and your load balancer, that sits in front of that, or scalability and geo-redundancy and all that kind of stuff. But that's outside of the scope of this. But let me just see. Yeah, absolutely. So what they said on the gatekeeper, yeah, that's the question. I assume the internal layer to talk to internal routing. Yep, I have understood. Yep, that's 100% correct. Let's look at Dan. I love how you do teach about this at YouTube channel. Yep. This is exactly the same thing. Something I remain confused about is integration testing on the controller level. If I recall, you used Web Application Factory for testing control. Do you have any suggestions, YouTube channel, about testing controller that is security protected, authorized? Yeah, absolutely. You create certain headers and certain tokens just for testing, and there's also a library that I created called Invisible API that hides certain endpoints, from the outside world. I'll create a session. I'll create a session about that. Dan, I will make sure that there's a session specifically about, building secure end-to-end integration tests or acceptance tests. Okay. How to see again the recorded video? I don't know. Carter, how do people see again the recorded video? It's going to be published on the website, right?
Yes, I thought I would jump in and help with that one. Yeah, so we are recording this webinar today. So the recording of all of this presentation will be posted on the Syncfusion YouTube channel as of tomorrow around 10 a.m. Eastern Standard Time. So you can find it on there, and we will also have an email going out to all attendees and registrants. So if we'll be sending it to you as well. So if you want to go check it out tomorrow, you can go on there. And if next week, we should be sending you an email with that and any of the follow-up questions and any other details from there.
Okay. Let's go a little bit crazier, shall we? Let's say, for instance, if this is really true, right? If this theory actually stands true, if this is the entirety of Microsoft team in here, every single employee, every single team out there, then you can actually see the bigger picture in here. If you go and say something to the effect of, here is Microsoft, we're trying to offer services like these. We're sitting in the middle, just like this. And then, maybe we're relying on a third-party providers to build our system. So let's say this is here is Syncfusion. Syncfusion is sitting here and providing us with UI components, right? And maybe right in front of us, you have something like the World Health Organization. The World Health Organization takes our tools and make decisions, for the rest of the world. If you look at this pattern, you will notice that Syncfusion here or any third-party provider become a dependency for us. And we are purposifying these dependencies and building systems and tools. And then the World Health Organization will take our tools and kind of expose these capabilities to outside world in terms of decisions, in terms of, reports, in terms of whatever is out there. The whole world just works like that. No matter how much you zoom in or zoom out, from the galaxy system to the atomic system, you will notice the exact same pattern, the fractal pattern, repeating itself over and over again. But if that's really true, then the real question here that actually kind of, lends itself to us, let's zoom in really, really close here. What if I picked up one of these components like a scheduled service, just a simple C# class that does things, right? Business logic, and we dissected it. If I look inside that service in here, does it actually follow the same pattern? The more I zoom in, the more I put it under the microscope. Let's take a look. So if I go here, every service that you will ever build, will have at least one of these three, if not all three of them. Regularly, usually, if you're building something super serious, you're going to end up with all three components in there. What are these components? The service does the validation. That goes back to the question from earlier. You're having data coming in and you're running validation on that. So you're making sure that the data is in good shape before you run any processing or operations on it, and before you persist in the database, you don't put faulty data in there. And then after you do that, there's processing piece that happen in here, right? So this processing, basically, maybe it's mapping your view model, your model into a view model. Maybe it is, doing a conversion or calculation. Maybe you want to calculate the tax on some payment, and some purchase processing. Whatever you're doing in there, that's processing. And then at the end here, there is an integration. This is where you go and call that storage broker that we talked about to kind of call the database and kind of persist the data in the system. So that smaller component in here actually has a dependency and has a purpose, and it has an exposure layer, because your validation is your front door. Before you actually enter the place, they have to check, whether you are in good state before they actually let you into the certain place that you want to enter, right? So that's your validation and processing and integration. Even at the simplest, smallest piece in the system, the pattern continues to repeat itself. Now, let's see if people here were paying attention. Do you guys think it gets any smaller than that? Like if I pick up this validation component, for instance, do you think it also applies the same theory? Do you think it has, something that it relies on, and something that represents a purpose, and something that represents an exposure? 10 seconds. Yes, no. What do you guys think? Hmm. Yes, validation will have an input exposure. That's right. That's true. It's even prettier than that. If you look at the validation layer, when you run your validation, it's not just validation. There's actually three types of validations that you can run in a service. What are these three types of validations? There's something called structural validation. What is a structural validation? When you go and say a name should not be null, empty, or white space. A date is supposed to have a year and a month and a day in it, right? A GUID is not supposed to be empty. That's called structural validation. It doesn't really care about the actual content. It just says, does it appear, is its exposure, the data exposure, does it appear to be successful? Does it appear to be working? That's number one. Okay. And then there is the next stage would be logical validation, where you go and say, does the date of birth that was entered into the system match the minimum age that someone can have or enter in that system? Like, for instance, you have a schooling system, you cannot be over 16 to kind of enroll in that particular course, right? If someone enters a date from the 1900s, it's not going to work out. So even though the data is structurally correct, it's logically incorrect. Okay, the same thing happens with any piece of information that you may have, right? Any possible piece of information that you want to enter, like for instance, a price of some, item, doesn't make any sense, in terms of, the quantity, whatever you're doing logically to validate internally to make sure that things are working properly. And then the last layer of validation here is called external validation, where you have to go and call the database to make sure that a student is actually valid and that's actually exists in the system, right? Yes, structurally also validates the data type, for Ryan's point. So external validation is when you go and say, does this student actually exist in the database? This is validation, but you can't do it internally and you can't do it structurally. You have to go call an external resource to actually do that validation. See, even the validation piece, this is even a microscopic level. When you're building your system, it also embodies that theory, the tri nature of everything. It has an exposure piece, it has a purposing piece, and it has an external call piece. And that system will continue to repeat itself over and over and over again. The more you dig into things, you will find it everywhere, right? It's a lot more like when people thought at some point in time that an atom is the smallest thing that we know of in the universe. And then they realized, wait a second, an atom is not, funny enough, it also has three components, electrons, neutrons, protons. But they realized that an atom also has more components within it. Some of you might know already about this. If you go and say, what's inside a neutron? If you look inside a neutron in the universe, you'll find the quarks, right? You'll find three pieces inside that neutron that actually support that system and they communicate with each other like that. You'll find that tri-nature theory. This is really not about software. I don't know if anyone picked this up yet. It's more about, being able to look at a system, no matter what this system is, whether it's hardware, software, you're making a program, even if you're even if you're writing an article, if you're writing a research, you want to start your research by talking about the prerequisites, right? Maybe you're writing a research about courses. You need to talk about the prerequisites, and then you need to talk about the content of the course. And then at the very end, you talk about the outcome, what you expect to learn after having that course. Again, dependency, prerequisite, operation, content and purpose, and then exposure layer, which is what you expect to be an outcome, measures of success if you're doing a research, and so on and so forth. Bilal here is asking, does CQRS pattern can also be used with this design, or that is something else? So, I don't personally use, that pattern, but it doesn't conflict with this one. Like you can always, like, in CQRS, you're basically going and saying I'm gonna separate my reads from my writes, right? And if you're separating your reads from your writes, you still need an exposure layer, you still need a dependency layer, you still need a business logic layer. So if this is your student service read, like this, student service read, this will be student service write. And this one will need a storage broker like this, and this one will need a storage broker as well. So see how the pattern can live on top of existing patterns, no matter how you break it, because you don't actually even need to consciously know about the tri nature of everything to build systems that follows it, because it's already there. It's like DNA, it's already embedded. But when you have it in mind while you're building your systems, you'll know where to put your code. Like you will see I've seen a lot of code where people put the business logic in the controller, in the exposure layer. Even worse, they'll put the DB context, the dependency in the controller layer or the API layer, right? So that's a mishmash of having your dependencies and your logic and your exposure layer all in one file, right? The pattern is still there. It's just the code structure is really hard to maintain. Please, could we also get the draw.io file for reference? Absolutely. Carter, I'll share the draw.io file with you. I don't know if do you attach things in the course as well? How do
Oh
you?
yeah, we, we
Okay,
can we can definitely set that up. So yeah, if you would share that with us, we can probably include a link in the YouTube description. We can also include some attachments or links into the follow-up email that will be going out.
absolutely. Okay, then. Thank you for that. I'll give you the file then. Okay. And for the people, wanting to open this file, you're just gonna need to go to draw.io, like a web page, or just download this is a desktop application. It's for free. You don't have to pay anything for it. It's beautiful. If you love this application and you use it, please sponsor it on GitHub because it's actually open source. So just go out there and get them some coffee or something. Okay, so back to this one. So back to this system. So you can see the system continues to kind of repeat itself over and over again. Now, what's an example of a system that actually follows that? I'm going to show you examples of systems that I built inside of Microsoft, that follows exactly that same pattern. And then I'm going to show you examples of systems that I built outside of Microsoft that follows that same pattern. I'm going to show living, breathing systems in production. If any of you have seen, Daniel Roth on the Blazor team presentation, let me find that one for you. So in here, building enterprise grade. I don't know why everything in caps like this. If you go into the last .NET Conf, session we had just last year, you will notice that Daniel Roth was demoing something very interesting. This is one of the very first, very first enterprise level Blazor applications that were built. We used Syncfusion heavily to kind of run this system. Most of the visualizations and all these nice components are there thanks Syncfusion was giving us the ability to kind of have Office Fabric theme because that's a coherence and design requirement for us. But this enterprise system is down to the last piece of detail following that tri-nature of everything is what I call the standard, the engineering standard. It tells you how to write the code, where to write the code, why you should write the code, right? So these three questions, it answers these questions for you. So it doesn't matter whether you've been in the industry for 25 years or you've been in the industry for 25 minutes, you're still going to be able to make a contribution from day one. As an engineering manager, when I look at things like these, my goal is to help people. If you have someone new coming into your team and they're sitting around for a month or 2 months just spinning around in circles and not able to create any pull requests, it makes them sad. I don't want people to be sad. I want people to come in and be able to contribute from day one. So what if we gave them an engineering standard that allows them to write code from day one, especially if you enforce pair programming, so you can actually write a feature without having a senior person or a pair of any level working with you and helping you build test-driven development together, which is just a completely different session, team culture, governing dynamics with teams and systems architecture and stuff like that. It's crazy. But what are other systems that I can show you as well? I built this system for all of us, for all the engineers around the world. This is a not a Microsoft affiliated project that I built, something that I built for myself and for the rest of the world. I said, okay, I'm a simple guy. I like to simplify things. If I can break, according to that engineering standard, every possible activity that a software engineer does, then maybe we can give engineers a little bit of a confirmation or affirmation that this engineer is actually doing great. Where do they stand? What do they need to invest in? What this system does, it looks at your open source code and it generates a resume out of it. So you never have to write a resume about yourself again. Every time you write code, let's say you're writing a code that integrates with SQL database, it will go and say, oh, this person actually knows how to write integration pieces, with other systems. It will look at your code and it will extract that information from your code. It'll even go and say, okay, here's the projects that this individual have worked on. And if you're still within 3 months time frame working on that project, it will stay present. If you're not, it will say this person have ended up working on this project on October 2021, whatever the date may be. Okay, so this system generates, your resume automatically out of your open source code. But more importantly, it will tell you even some interesting insights about yourself. Are you a coder or a developer? Are you a programmer or an engineer? Are you an entrepreneurial engineer? What are you? Based on your code, again, it will tell you, how much effort and what kind of level of architecture that you're building in your system that qualifies you to be one level or another. It'll even tell you based on your code whether you're leaning back end or leaning front end. Some people have this cursor all the way to the left. They don't do front end at all, right? And some people have a little bit of leaning. As you may know, I do a little bit of front end, but apparently my back end is more than my front end, so therefore the cursor will lean a little bit to that direction. It'll even go and tell you here's your strengths and weaknesses. Like here's how much you contributed to building API controllers, and here's how much you contribute to building infrastructure components, foundation services, base. I built this system to help engineers everywhere know what their true worth is. So nobody can undermine you or underestimate you. But more importantly, I want you to know where you need to invest your next, how do you evolve, right? A lot of engineers come to me 21 years now in this industry. A lot of engineers would come and say, I don't know what to learn next. But if I go and say, it seems like you're a little bit weaker on the page development, why don't you go build a little bit on that? Why don't you go and kind of expand that? Ideally, the ideal state is that all of these should be balanced. But not just that, it will tell you about your progress and performance. But not just that, it'll go and say how long do you normally take to develop a particular feature and when was the last time you used that feature. So how long is super important for you and the people working with you. So if someone comes to you, one of the hardest questions engineers have to answer. People come in and say, okay, develop this feature for us. How long? When are you going to be done? A lot of engineers be like, I don't know, maybe 2 days, 3 days. It's a very hard question for the engineers because there's a lot of unknowns. But if you have a system that's studying on daily basis every time you merge a pull request, what you're actually working on and kind of balancing the average time, you will be able to just throw the feature at the system and say, here's, I need 2 controllers, 3 orchestration services, 5 foundation services, and 5 brokers. And the system will say, your average time is about 3 weeks. Throw another week on top of that just to give yourself a wiggle room, and you have the most accurate data-driven decision about how you estimate a project. All of these components are built with Syncfusion. This is your grid components and all that kind of good stuff. But not just that, it will go and say, let me see what technologies you're working on, how much you worked on all of them, and when was the last time, how recent are you with the technologies that you're working with, and so on and so forth. System like this, you will see in here open opportunities. Oh, you didn't work enough on brokers. So here's another open source project that follows the standard that says, I need someone who knows how to build brokers. Let's say you're not on a team and you don't even know me, and you're saying, how do I build brokers like these? I'm going to give you a code example of how to build a broker of a merged PR. I'm going to give you a chapter from the engineering standard that tells you what brokers are and how they work. I'm even going to give you a YouTube video on my channel that shows you how to build brokers. And if none of that works with you, you can just go and click that question mark and it'll take you back to me at LinkedIn. So you can ask me any questions and I can pair with you. So you have no excuse. I will teach you the standard one way or another, right? You want videos, you want code. The reason why I diversified it like this, because I understand that everybody out there learns differently. Some people learn through code, some people learn through video, some people learn through reading, some people learn through asking questions. But what if we offered all of this to people? And once you're ready and you say, yeah, I can implement this decentralized social media platform, component, just click go. And when you click go, it'll tell you what exactly to do, and you can contribute and start working in the open source projects. So that's a real life project. What else did I build in the past? A really, really old system called iRecruiter that helps, recruiters kind of store their data and all that. All of these systems are built according to the standard. If you go to my GitHub repository now, you will find a ton of repositories that follows that standard. A good start would be OSSS, an open source schooling system for the financial disadvantaged students around the world. We go to schools and we tell them, use our system if and only if you're going to redirect the funds that you dedicated for the software development to kind of buy meals for the students and give them gifts, maybe buy them a laptop or whatever the case may be. We don't take anything from them. 7,664 commits, over 56 contributors in that system. And if you look in the code of this system, in here, you will notice we have brokers, we have services, and these brokers basically, embody these primitive operations, insert, select, calendar. If you go a little bit into the services layer, let's go to the services layer real quick. You will find you will find that your services layer does the dependency injection for your dependencies. It's basically saying create a course async. You'll find some really nice gotcha in there, something I invented about 2 years ago called exceptions noise canceling. Please watch this and read how I do exceptions without kind of, muffling your ability to see the actual the business logic that your method is doing. Look, it's doing validation, processing, and integration, just like that. And if you go all the way up to the controller, like this, you will find in the controller layer, all that this guy is doing is that it's calling the service and calling the call and then mapping the exceptions into the proper HTTP status codes. If the student already exists, we send 409 conflict. If the student has any other validation issues, there's bad requests. There's a little bit of conversation around problem details using exceptions. I can talk for days and days and days. This is really just the tip of the iceberg here. So there are systems out there that follows the standard. Where do you find the standard exactly? I will give the link to Carter. If you go and type in the standard on GitHub, you'll find a massive community on Discord. Over 160 engineers, 23 online right now. You can jump in and ask people questions from all over the world, and they will tell you, yeah, we're building brokers and servers and controls. You don't even have to know me. You can just go and talk to these people, and they'll tell you, yeah, we're following the standard and we're implementing it, and here's how we're doing it, right? It's a very long list in here, but it tells you everything you need to do to know from the beginning till the end. It's a compendium. It will tell you literally everything that you need to know from a simple idea all the way up to building UI components. These pieces that I just talked to you about having a base components and a components and a page and all that, all of this is in there. and I continue to evolve this standard for myself and for the rest of the engineers around the world because I want you to be happy. I want you to build software and be excited and be happy about what you're building and be excited about. I want you to think less about how you're doing it and think more about the purposes that you're trying to fulfill by doing it. And I hope I can be a little bit useful. I hope you find something useful in this session. I hope that this made you a little bit happier, more hopeful to build more systems. Maybe have a great idea and put a dent in the universe. Just go out there and change the world and build the next big thing. That's it, Carter. I don't know. I don't have anything else.
Well, I think you gave plenty right then. I think you're right. That was great. And I think, like you said, like I think a big thing of like getting into development, everything is always that inspiration and pushing and giving like that motivation of getting out there and really continue building. I think that's a great way to end it off on there. But I do want to say, I know you had mentioned the GitHub link. I did go ahead and add that link
Thank you so
into
much.
the chat window. So if
Yeah.
anyone wants to check that out, I also believe I saw one of the attendees mention that they had adopted the standard and it
Yep.
really helped with ramping up their developers. So I
Yep.
do,
Yep.
do recommend everyone check that out. Um, as we are wrapping up into our webinar today, I just want to make sure if anyone has any questions, you can go ahead and submit them now. If I know we've kind of reached the end, but if we have time, we can go ahead and answer some of those questions. And if not, we can leave this chat window open for a little bit and we can get to your questions at a later date and get back to you shortly.
I see a question here. It says, "Where is the try-catch tricks?" Okay, so here's a couple of things for you. Are you ready to be mind blown? Because this is not something you've seen before unless you've seen my YouTube video. If you go into, let me show you it is. Let me show you it in the code first. And then let me show you. Let's just pick up literally any project out there. So look what I do here. If you go into a service, you know how, okay, okay, you guys are in for a good one. We keep saying object-oriented programming, object-oriented programming, object-oriented programming. Great. But objects are not 2D. Objects are 3D, right? And yet, when we design our systems, we continue to design them in the 2D space. So you'll see an interface and a service, and the service has everything in it. So I thought to myself, how about I multi-dimensionalize the object? So I'm gonna go here and create an object like this. Imagine that this is your service, and you have another aspect behind the scene of your service like this, and these all are connected with each other. What does that even mean, and what's that has to do with software engineering, right? If you visualize like this and you say this is my service, I decided to break every single object, every single component that I have into certain aspects and dimensions. So let's say, for instance, this front in here is your logic. That's the front door. When you look at your service, you see the logic. That's it. And then from this side in here, maybe you have the validations aspect. So you don't put all your validations in your logic. That will just make it hard for the engineers to read, what you're doing. So I said, let's have another aspect called validations. And then maybe there's another aspect in this three-dimensional space where you're handling and taking care of all the exceptions in your system. So from the top in here, you're basically going and saying, I want to handle the exceptions. So this way, you're looking at your object, your one service, in a 3D space. C# is one of the only languages around the world that can actually let you do that through partial classes, right? You can partialize one class and create a whole bunch of pieces and connect them all together. What does that look like in the real world? Let's take a look. Let me actually open up Visual Studio for you because I want you to actually see this in the real world. So let's just open one project in here and let's see what that looks like. Here is see, I have a 64 gig of RAM on an i9 and it's still taking a little bit of time. I'm very sorry, guys. You have to pay minutes and seconds out of your lives because of the hardware. Anyway, let's just see what this looks like. I hope the code is visible to you. Do you guys see Visual Studio right now? And let me kind of minimize this window a little bit so you can see everything. What do you think, Carter? Do you see the
Yeah.
screen? Yeah,
Yep, it's
okay.
popped up for me.
Awesome. So let's do this. Let's go and look at one of these services, right? This here is an open source project called Ta'arafu. It's a decentralized social media platform, so nobody steals your data and spies on your, private conversations and family pictures and all that kind of stuff. I'm building this to kind of, say here's a decentralized social network. You spin up your own social network and invite your friends there. But if you look at one of these services like a post, you're basically posting a social media post. You will see this try catch guy sitting in here. What does this guy do? This guy is a function that takes a function. And whatever exception comes out of that function, this guy will handle it. So if I go right click and go and say go to implementation, look, it takes a function in here, a delegate, and it says call that function, whatever it is, and let me handle all the exceptions and deal with all the exceptions that come out of the communication for this function. So this way, when you're looking, see, it says up here partial, and in Visual Studio, you see them nested under each other. So this post service now is 3D because it has this aspect and it has this aspect. One part that does the validation, one part that does the exception handling. There will be more, of course. It will be tracing and rollback, and I have a lot of stuff in my pocket to show you, but in general, this is how this try catch works. You're basically going and saying, I don't want to have try catch in here. I want to see my business logic. So let me hide that away behind in a different in a different aspect where we can handle all the exceptions that may come out of an API and localize these exceptions so we can work with them. A whole different story called localization categorization, unwrapping wrapping of exceptions, which is also another novel thing that I could just take an entire session to talk about. I don't know, Rick. Are you yet entertained? I don't know. I hope you're entertained. I don't know. It's a good trick. It makes your code really clean. I see Bilal here saying, what about events generated by system itself in this design? Usually we have request and response flows. Well, your request and response are just IO, so that's at your exposure layer, and then you're channeling that through to your purpose layer. Your purpose layer will try to handle these communications and basically rely on your dependencies, if there are any dependencies, to take care of that. But there's also a pattern that I coined called the cul-de-sac pattern that kind of allows you to actually create and generate events within your service. And these events will basically allow you to kind of have your own internal queue. Go to my YouTube video and watch anything that says cul-de-sac. You'll be mind blown, I promise you. Any other questions? Comments? Concerns?
So yeah, and while we give some time for anyone to put their stuff in, I know Hassan had just mentioned his YouTube channel. I did want to go ahead and share that in the chat as well. So I am attaching that currently. I'm also going to include the Syncfusion YouTube channel since I had mentioned that we will be posting the video on there shortly. So for Hassan's, you'll find all of the great content that he had mentioned earlier in this webinar, as well as the content he just mentioned, as well as on the Syncfusion YouTube channel. You'll find by tomorrow the whole recording of this webinar. So I
Okay.
posted that down in the chat.
Okay, design and architecture. And here is also, because I know I'm gonna forget, design and architecture. See, I can design systems, but I can't tie my own shoes. It's just weird. Here's a oh, can I send a file? I can't. Okay, I'll just send it to you directly then, Carter. If
Okay,
that's okay.
cool.
Any other questions? Is using partial class along, I'm sorry, Bilal, any thoughts about domain-driven design? Yeah, see, domain-driven design doesn't really tell you how to write your code. It tells you that make sure that your engineers and your business people are speaking the same language. A lot of people would like to take that into the direction where they say, oh, your model should have the business logic and you should share it across multiple distributed systems. Count me in as a naysayer. Dan says, I'm entertained. Yay. I'm really happy that you said that. That's the whole point of this. A lot of people think I'm a software engineer. I'm just playing tricks. I'm going around town playing tricks, and people just say, drop a coin. That's your like button, and sharing it. That's your coin in there. I'm really happy that you're entertained. I learned about the try catch from your channel, and I'm starting to use it in my code, and my team members are also entertained. I'm glad that people like that. You just need to apply yourself in code. You can produce some of the most beautiful code too if you just kind of make it perfect. You guys have no idea. I have stuff in my pocket that's gonna blow your minds. Time is very little, Carter. What are we gonna do with with the time. There's all these fun things that we want to implement.
Mhm. Oh, that is always the question.
And then Sharaf Mansour said, is using partial classes along with partial methods to do things like logging will still be valid. So partial methods is just how do I put this nicely? It's just a bad idea. I talked to Mads Sturgerson, about some of these things. I have yet to find someone who's using partial methods are more like your you're basically going and saying here's something that needs to be implemented and then go implement it somewhere else. You may as well put that in the interface. I don't think it's mature yet as a language, but partial classes for sure. Logging, tracing, rollback, all of these things. Absolutely, Sharaf. 100%. 100%.
Nice. And I know I think that's all the ones we have right now. So if anyone has any other questions, please go ahead and let us know. Like I said, even if we can't get them today, we'll make sure to check in with it. I think I just saw. Oh, the I just see Dan mentioning partial influences.
Yep.
Mentioned he learned it from you too. Nice.
Okay, I'm gonna go for a little walk now. This was fun to talk with you guys. It's sunny today, and unlike it usually is in Seattle area, but we're getting into spring, so it's gonna be fun. But I'm really grateful for this opportunity. And Carter, thanks to you, thanks to Syncfusion, thanks for everybody, coming in here today to give me the opportunity to kind of share these thoughts and ideas. Some of it is crazy, some of it is just, halfway there. But I'm pretty sure that you might find in some of it some use, and I appreciate you all. Thank you so much, Carter. You're awesome, Carter. I want you to know that. You're an awesome
you're
guy,
you're
you know?
awesome. No, but seriously, and you are awesome, and thank you so much for joining us today. I know, like me as well as all of the people here today, have enjoyed listening to your presentation, and Syncfusion's very glad to have you on here. So, thank you,
Thank
and
you
we
so
hope to
much.
see you again.
Thank you so much, brother. Thank you all. Take care. Bye.
All right. Bye, everyone. Hope you have a great day.